Okay, so this is number 2 on the test 3 study guide. So we're given this graph and it wants us to answer the questions on the bottom. So is n, our exponent, even or odd? So remember when we look at even or oddness of a graph, we want to look at the y endpoints of our graph. So here we can see that this left part of the graph here, its y endpoint is going up. On the right side, its y endpoint is going down. So remember, if your y endpoints are going in the same direction, your n is going to be even. If they're going in opposite directions, our n is going to be odd. So here they're going in opposite directions. One is going up, one's going down. So n is odd. Okay, and is our k less than 0 or greater than 0? So here I tend to think about k being kind of like our slope. So remember how when we have, Okay, so remember when we have a linear equation or a linear function, if our m was less than 0, we had a negative slope, right? We start up in the left and we end in the right. If we had a positive slope, remember we started down in the left and we ended up in the right. So I kind of think of our k's being the same way. If your k is less than 0, you're going to be in the top left quadrant and the bottom right quadrant. If your k is greater than 0, you're going to be in the bottom left quadrant and the upper right quadrant. So here we are in our upper left and our bottom right. So we are going to know that our k is less than 0, our k is negative, like a negative slope. So is this function symmetric with respect to the x-axis, the y-axis, the origin, or none of these? So we know it can't be symmetric with respect to the x-axis, right? Because no functions can be symmetric with respect to the x-axis, then it wouldn't be a function. It wouldn't pass the vertical line test. So that's out. So remember, I think of symmetry as where can you fold your graph so that your quadrants line up, right? If we tried to fold it on the y-axis, then we would have, a quadrant up here and we'd have a quadrant down here that our graph fills. But we can't fold it on the y-axis. But what we can do is we can fold it here at the origin, and then our quadrants or our graphs will line up together. So like I said, y-axis is out, so it has to be the origin. Okay, so state the domain using interval notation. I know my paper is kind of a mess here, so let's look at the graph. So remember, the domain is all of our x values that our graph doesn't necessarily hit, but if you drew vertical lines to the graph, where it would hit. So our x values start all the way on the left. So we know it goes all the way from negative infinity. And remember, we use a parentheses with that. Our infinities are always parentheses. And so we go from negative infinity and we start going, but we get to here and we never cross 0. So we get all the way up to 0, but we never cross it. So this is going to be a parenthesis because it doesn't include 0. Union. And then remember, we do the same thing left to right on the other part of the graph. We start here where we're really close to 0, but we never touch it. So we start at 0. And then we keep going, go all the way to positive infinity. And that has a parenthesis as well. So that's our domain. And it wants us to find a power function of the form y equals a times x to the p that goes through these points 1, 2, and 672. So I'm actually going to do that in a different video because I'm kind of running out of room here. So click on the next one for that question.